Manushree Holkar. I am in 8th standard ICSE board. Today's subject is chemistry. Lesson number 7, hydrogen. So let's start. Hydrogen is the lightest of all the elements. It is the first element in the periodic table. It is the most abundant element in the universe. And it is present in the maximum amount in the sun and the stars. The heat and light of the sun are produced by the reactions in which hydrogen atom combines to form helium. Now let's see discovery of hydrogen. In the 16th century, Paracelsus found that an inflammable gas, which was then called inflammable air or phlogiston, was produced when a metal was dissolved in acid. And in 1776, Henry Cavendish, an English scientist, prepared hydrogen gas by the action of the acids on various metals. Hence, the credit for the discovery of hydrogen goes to him. He also recognized it is an element. In 1783, Antoine Lavoisier, a French chemist, named it as hydrogen from the Greek words hydro meaning water and gens meaning creator, because when it burns it creates water. Did you know hydrogen is the main component of the Jupiter and the other gas giant planets? Now let's see occurrence of hydrogen. Hydrogen occurs in nature, both in free and combined state. Free hydrogen is scarce in the Earth's atmosphere. In combined form, it is present almost everywhere. Hydrogen is also present in the combined form in all living beings. Water that covers 3/4 of the Earth's surface is an oxide of hydrogen. Chemical compounds such as acids like hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3, phosphoric acid, H3PO4 and acetic acid CH3COOH, and bases like sodium hydroxide NaOH, potassium hydroxide KOH, calcium hydroxide CaOH2, and hydrocarbons such as methane, ethane, paraffin wax, and among others. Proteins and lipids also contain hydrogen. Hydrogen element exists as a diatomic molecule H2, which is a gas. Since hydrogen is not available in its free state, it must be prepared from its compounds. Hydrogen can be obtained from these compounds by getting it displaced by more reactive metals. These reactions are called displacement reactions. Hydrogen can also be liberated when water reacts with metals, or when an electric current is passed through it. Electrolysis. Now let us learn about various methods for the preparation of hydrogen in details. First, let's see displacement of water by metals. Highly reactive metals like potassium, sodium and calcium, when treated with cold water, gives metallic hydroxide and liberate hydrogen gas with evolution of energy. Sodium and potassium react violently with water. The reaction of potassium with cold water is so vigorous that hydrogen evolved catches fire. The reaction of calcium with water is not very violent. Magnesium reacts with hot water to form magnesium oxide and hydrogen gas. Mg plus H2O gives MgOH2 plus H2. Reaction of aluminium with steam. 2Al plus 3H2O gives Al2O3 plus 3H2. Aluminium plus steam gives aluminium oxide and hydrogen. Reaction of zinc with steam. Zn plus H2O gives ZnO plus H2. Zinc plus steam gives zinc oxide and hydrogen. Reaction of iron with steam. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Iron plus steam gives iron oxide and hydrogen. Metals like gold, silver and copper do not react with water. Now let's see how to prepare hydrogen from water by electrolysis. Pure water does not conduct electricity. By adding a few drops of dilute sulfuric acid to water, acidified water, it conducts electricity. On passing an electric current through acidified water, it dissociates into hydrogen and oxygen. This process is called electrolysis of water. Now let's see electrolysis and associated terms. First, electrolysis. The process of decomposition of chemical compound in the dissolved state or molten state by the passage of electric current. The process of electrolysis requires an electrolytic cell, an electrolyte, 2 electrodes and a power supply. Now let's see second term, electrolytic cell. A container made of glass usually serves as an electrolytic cell in which electrolysis is carried out. Now let's see third term, which is electrolyte. An electrolyte is a compound which in the molten state or solution state conducts electric current and undergoes chemical decomposition. Now let's see fourth term, which is electrodes. They are the conducting rods that allow electric current to enter and leave an electrolyte. They are usually made up of inert or unreactive substances and they do not react with electrolyte. Now let's see displacement of hydrogen from dilute mineral acids by metals. Metals which lie above hydrogen in an activity series displace hydrogen from dilute sulfuric and dilute hydrochloric acid. The reactions of mineral acids with potassium, sodium and calcium are highly exothermic and explosive. Metals such as magnesium, aluminium, zinc and iron react with mineral acids at ordinary temperature and liberate hydrogen gas along with the formation of corresponding metal salts. Lead is not used to prepare hydrogen, although it is placed above hydrogen in the metal activity series. This is because the reaction is low and the products lead chloride PbCl2 or lead sulfate PbSO4 formed are insoluble and they form a layer over the metal preventing further reactions. Copper will not liberate hydrogen from dilute acids because it is placed below hydrogen and in the metal activity series and cannot displace hydrogen from the acids. Nitric acid is a strong oxidizing agent and it liberates nitric oxide or nitrogen dioxide, therefore it cannot be used to prepare hydrogen gas. For example, magnesium reacts with hydrochloric acid to give magnesium chloride and hydrogen gas. Second, iron reacts with hydrochloric acid to give ferrous chloride and hydrogen gas. Third, zinc reacts with dilute hydrochloric acid to give zinc chloride and hydrogen gas. Fourth, aluminium reacts with sulfuric acid to give aluminium sulfate and hydrogen gas. Now let's see displacement of hydrogen from alkalis by metals. Metals such as lithium, sodium, potassium are called alkali metals. The hydroxides of these metals are called alkalis. Metals like zinc, lead and aluminium react with hot alkalis to liberate hydrogen gas and form soluble salts. Now let's see laboratory preparation of hydrogen. Hydrogen can be prepared in the laboratory by reacting granulated zinc with dilute sulfuric acid or dilute hydrochloric acid. Granulated zinc contains copper as an impurity which acts as a catalyst and increases the rate of reaction. If pure zinc is used, the reaction will be very slow because the layer of gas insulates the metals from acids. Zinc is preferred over other metals in the laboratory preparation of hydrogen for the following reasons. The reaction of metals such as sodium and potassium, which are more reactive than zinc, is uncontrollable and explosive. Hence, metals that are more reactive than zinc are not suitable for the laboratory preparation of hydrogen. Second, calcium and magnesium are expensive. Zinc is more reactive than other metals like iron, tin and lead, capable of displacing hydrogen from dilute acid.